Hey guys, so here is the second part of this example video. Sorry for splitting it up, had some issues. So, what we are told is that a rock is thrown up from off of a cliff. Its height in meters can be modeled in seconds as a function of time, right? So we say that its height can be modeled as a function of time. So what that means is that the input of the function is time. So imagine, if you will, someone standing on a cliff and they take this rock and they throw it up in the air and it goes up and it comes down, right? So we're assuming that it comes down not on the cliff. So this function can model that height. Now, the first question here is simply, what is the height the rock was thrown from? In other words, kind of, what is the height of the cliff plus the person throwing it? Well, to figure that out, we just really simply think about this for a second. So if I'm just looking at the first quadrant, right? We've got 0 here. The height the rock was thrown from means I want to know the exact instant that rock was released. That's when it was thrown. So what was the height then? And all we have to do to think about that is think, well, what does times 0 mean? Times 0 is that instantaneous moment, that exact moment in time where the rock was thrown. So to answer this question, what was the height the rock was thrown from? We simply have to figure out the y-intercept. Well, luckily, we are given this form in standard form, this function in standard form. So we know it's 3. So I know the rock was thrown from a height of 3 meters. That's it. Bam. No work done. Moving on. Okay? Now, second part of this problem. When did the rock reach its highest point? And what was the highest height it reached? Now, those are two different questions asking for two different things, but they're similar. When did the rock reach its highest point? That's asking for a time. So that's asking for the input. What was its highest height? So that's asking for the height. That's asking for an output. Now, since it says highest in both of these, we know that when it's talking about a quadratic, its highest point is always the vertex. We also can look at our a value and see that it's -5. Since that's negative, right? Remember, our a tells us whether our graph opens up or down. Since a is negative, it opens down. So its highest point will definitely be that vertex. So problem number 2 is asking us to find the input and output of our vertex. Since we have standard form, that's really easy to do. We know that the vertex occurs at h, which is equal to -b over 2a. And that's it. Now we just have to plug those in. So for this problem, it reaches its highest point at so b is positive 14 over 2 times a is -5. We're going to simplify this, so I've got 14. 2 times -5 is -10. But I already have this negative out here, so the negative and the negative cancel, and we just have 10. So we have 14 over 10, which is just a lovely 1.4. Now, you could simplify this down and say 7/5, but here's the problem, is if I tell you that, hey, this rock reached its maximum height at 7/5 of a second, that's like, wait, what? 7/5, how long is that? I don't really know. And maybe if you're clever and good with you're like, okay, it's between 1 and 2. But if I say the rock reaches its maximum height at 1.4 seconds, you're like, oh, cool, gotcha. Okay? So understanding the context of the problem, the best way to form and report your answer is a really good idea. So there's our input. Now, that is the answer to the first part. The rock will reach its highest point after 1.4 seconds. The next part of this question is, what is the highest height it reached? So that just simply wants us to find our k value. To find that, I just simply need to calculate h of 1.4. Now, these h's here are different. These are like the vertex h, not this h. So to find h of 1.4, we could absolutely plug that in for our t, go through those calculations, do that, right? But if you remember, if we type that function, get this into focus, there we go. If we type that function into our calculator, we can hit second and y equals and get to this nice little table. From this table, we can put our x value in here, in this problem, our 1.4, and we get our y value out, which is 12.8. So that means this equals 12.8. So we don't want to just leave our answers like this. This isn't complete. We want to state our final answer as a statement. Anytime we're dealing with a word problem, a modeling problem, we want to use words to answer it, right? We need to use complete sentences even. So this question said, when did the rock reach its highest point? What was the highest height it reached? Our answer to that should say something along the lines of, the rock reached its highest point after 1.4 seconds. And its highest point was 12.8 meters. Okay, now any sort of kind of combination of those, any order, as long as it makes grammatical and English sense, that's fine. Right? You can combine that, you could say the rock reached its maximum height of 12.8 meters after 1.4 seconds. That's perfectly okay as well. You just want to make sure that you have all of that information in there in a nice, concise, grammatically correct sentence or two. Okay, moving on to problem 3. Problem 3 simply asks us, when did the rock hit the ground? All right, when did the rock hit the ground? Well, the rock hit the ground when it had a height of 0. So what I need to find is, when does h of t equal 0? Well, we have a big giant function or an equation that only does this, right? Quadratic equation. The quadratic equation only solves when a quadratic function equals 0. So let's use that. So what we're trying to find is when negative 5 t squared plus 14t plus 3 equals 0. So we're going to grab our calculator to do this for us. Don't get crazy. And so we have that x, not x, t, negative b plus or minus the square root b squared minus 4ac all over 2a. So I want to go through and replace each of these with its correct value. So what we get is negative 14 plus or minus the square root of 14 squared minus 4 times a is negative 5 times c is 3. And I want to divide that by 2 times negative 5. Okay? Now, we're just going to grab our calculator and use it to do that for us. Okay? Don't get fancy. Don't get overly complicated. So negative 14 plus the square root of 14 squared minus 4 times negative 5 times 3 divided by 2 times negative 5. Now, I'm going to show you what I've got. Remember, I've got one of the newer calculators, so I actually have that lovely fraction button I can use. Make sure that when you guys are doing this, any of your negative signs, such as this negative 14 here, you're actually using the negative button and not minus. If you use the minus button, it's going to give you a whole different problem, a whole different solution. So I hit enter on that one, and I get, so that was with the plus, so what I'll do is I'll kind of split this into 2, and I'll say this is the plus version. I get negative 1/5, which is just negative 0.2. If I go back and do the minus version, I get 3. Okay? Check that yourself. Go through and do this whole thing yourself. Do not trust me on this. Do not take my word for it. Do this yourself. Okay? So, we have those 3 answers. Does that mean that the rock hit the ground twice? Right? And you may be thinking, well, yeah, you throw the rock up, it goes down, it might hit, and then bounce a little bit. But that's not what we're modeling. We're just modeling that initial kind of height of this rock. So we have to remember these variables, or these values are representing t. T is time. Does it make sense to say that the rock hit the ground negative 0.2 seconds after it was thrown? That makes no sense at all, right? We can't talk about negative time. Okay? So that means the rock hit the ground after 3 seconds. That's easy. There it is, right? We take the one that makes sense. In other words, the one that is contextually meaningful, the one that makes sense of the meaning of the problem, in the context of the problem, we use that. Now, there you go. The rock hit the ground after 3 seconds. I'm not going to erase this. We're going to jump on to problem 4. Problem 4 says, what is the domain and range of the model? Well, the domain and range of the model is very simple. Domain. What times make sense? It's a quadratic function. A quadratic function, in general, will always have the domain negative infinity to infinity. Every input will always work. You have to worry about anything making sense. That is the only way it gets eliminated. So as we just said, can you use negative times? No. Negative times don't make sense. So that takes out the first two questions. Can I use 0? Absolutely. So our domain is going to start at 0 and include 0. Can I have positive times? Yeah. Can I have all positive times? Would it make sense to talk about this model after 5 seconds? Right? Well, if you want to, use your table on your calculator. You're a second into the table. And I'm going to hit 5 to go for 5 seconds. Okay? If I hit enter, it gives me negative 52. So according to this model, I threw the rock up, it goes up in the air. After 3 seconds, it hits the ground. After 2 more seconds, it has now dug itself 52 meters into the ground. That doesn't make any sense. So it doesn't make any sense to go beyond the point where it hit the ground. So we're just going to go from 0 to 3 and cap it off. That's it. Now range. Remember, range is output, it's the vertical height. In this problem, what this essentially boils down to is what heights was the rock able to reach? Can't be negative, so that doesn't make sense. But we can be 0. Now, what was the highest height this rock reached? That's right, 12.8 meters. There you have it. Now, there's 2 more questions on this. They're not on my screen, and if I move my screen, I'm going to lose my video because I don't know why. So give me 1 second here. Pull this up. All right. When is the rock at a height of 9 meters? So here, I am asking this question. The problem is, I don't have anything to solve this. The quadratic formula only works when I'm solving a quadratic equal to 0. So what do? The first thing you need to do when doing any quadratic equation or inequality, first step, get it in relation to 0. So if you have a quadratic problem, get it in relation to 0. So to do that, I simply need to subtract 9 from both sides. Now, when I subtract 9, it doesn't affect my negative 5t squared or my 14t, because those aren't like terms. So I have plus 3 minus 9 will give me minus 6. Now this is something we can use a quadratic formula on. So that's what I'm going to do now. Now I'm going to use a quadratic formula to say that t equals negative 14 plus or minus the square root of 14 squared minus 4ac all over 2a. Now notice the only thing that changed in the quadratic formula is the c went from 3 to a negative 6. So if you still have the quadratic formula in here from when we did earlier, okay, you can just scroll up and select it. If you have one of the older ones, you can't do that. And so what you're going to want to do is you're just going to want to do the same thing we've done in the past. And this will always be second enter. And now I've got my quadratic up again. And so I'm just going to scroll back and change that positive 3 to a negative 6. So you can see right here on my cursor, I changed that positive 3, that was a positive 3, there we go, to a negative 6. I'm going to hit enter. I'm going to do it again and change the minus, so that was on a minus version, to the plus. Okay. And so what I get from this, I get two values. Now, if you look at my equals, it's not a normal equals. It's kind of wavy. And what that means is it's approximate, because we don't have exact values. You can't turn these into fractions. They're not nice numbers. And so we get approximately 0.528 and 2.272. Okay. Hi. So those are our two solutions to this problem. Now, like when we asked if it hit the ground, we only had one answer to that, right? And that's because one of them was negative, and we're talking about time. Here, both of our times are positive. So that makes sense, because if we think about what's happening, right? We started out 3 meters above the ground. We threw the rock up, and it reached a height of 12.8. So from 3 to 12.8, it passed by that 9 meters. And then it came back down from 12.8 and hit the ground at 0. So that means it went up and came back past 9. So it makes sense that it did it twice. Now, I'm going to tweak this question. And what if I said, when is our function greater than or equal to 9? In other words, the question changes now simply to, when is the rock at a height of 9 or greater? When is it the rock at a height greater than or equal to 9? We know when it's equal, right? Remember, first step in solving any inequality is to solve the equality, and that's what we just did. Now, I could use the table, I could set that up and go through that process, and that's great, but we can also use the fact that we know what this graph looks like, don't we? We know that this graph looks like that. It opens down. And if we drew a line at 9, it'd be right there. So when is this function above that line? Well, it's simply between these two values. So that means, let me give myself some room here. Okay, so that simply means that h of t is greater than or equal to 9 from 0.528 until 2.272. And the reason I have brackets here is because we're asking greater than or equal to. If I just said greater than, we would use parentheses. So there that is. Nice and easy, really simple, okay? You just want to kind of follow through these steps, go through piece by piece through these problems. Now the last part on this problem is to give this function in all three forms. Already given standard form, okay? So I'm going to erase that. So h of t equals negative 5t squared plus 14t plus 3. Now, for vertex form, well, I already know my a. And remember, vertex form is a times x minus h squared plus k. Well, we know the vertex of this was at 1.4 comma 12.8. So that means that this is going to be negative 5 of my a value times t minus h, so minus 1.4 plus k. 0.8. That's not bad. Now what about for factor form? Well, again, our a is the same, -5. Now in this case, it's a times x minus r times x minus s, where our r and our s are the point our x-intercepts. Our a is the same, and we know that this has zeros at -0.2. Let me double check that. Make sure I didn't make that up. Yep, -0.2, 0, and 3, 0. So that means our r is -0.2. So I have t minus -0.2, or t plus 0.2. And lastly, at x minus s, or t minus 3, and there we have it. So there's our standard form, our vertex form, and our factored form. So once you have those information, the ones that we've got throughout this problem process, creating the 3 forms is as easy as plugging it in. That's it. All right, you guys. That's it for this video. Hope you guys learned something. If you guys have any questions at all, please email me. I'd love to talk to you. Your next week is going to consist of a couple videos for polynomial functions. Quadratics are something that I have on next week's schedule, but you really should be able to get that done this week. Be done with it. That way come Monday, you can start the ground with polynomials, work on polynomials all week, make sure you have a really good understanding of those. And then the next week, get a really good understanding of rational functions and get that really down pat, and then we'll be ready for the test, okay? Do not look at those extra practice things as like, whatever, they're not great, I don't care. I cannot stress enough how important it is for you to go and practice those. Get that extra practice. Those activities ask questions in a different way than the homework does, and it gives you another kind of vantage point to look at some of these materials. So go look at those activities, especially for quadratics, polynomials, and rational functions. Look at them, work on them. It's going to help build up some of these aspects. All right, you guys, have a good weekend.